Hello, this is just a quick video on how to solve those gas law problems and which one to pick. So I'm going to go really fast through this. The PowerPoint is on the doc sharing. It doesn't have the problem solved though. Okay, so temperature has to be in Kelvin when you do gas laws. That's the crucial thing. Here's the equations. There's lots of pressure units. WIVA usually works with, or the program we have is usually dealing with kilopascals, but here's lots and lots of pressure units. Okay, so standard temperature, standard pressure, here's that. Standard temperature is 273. Standard pressure is 1 atm or 100 kilopascals. Now there's four things that affect gases. The amount of gas, which we measure in moles, the pressure, the temperature, and the volume. Okay? These are the four factors, and so it just depends on what you're doing. Boyle's law and Gay-Lussac's law and Charles' law assume that the amount of gas stays constant, so you're not going to deal with it. So we're not going to deal with moles or how much we have. So Boyle's law, Charles, and Gay-Lussac's all have different things that they assume stay constant. So Boyle's law assumes temperature stays constant. So if you get to a problem and it says the temperature stays the same, it stays constant, then you're going to deal with Boyle's law. Or if it says the temperature at the beginning was 25 degrees Celsius, temperature at the end was 25 degrees Celsius. Well, it stayed constant, so you're going to use Boyle's law. That's kind of a key to figure out what one you're using. So here's kind of an idea with Boyle's law. So here's your equation, P1 times V1 equals P2 times V2. It assumes the temp stays constant, and it states as the pressure increases, the volume will decrease. Okay, so the volume's going to go down. Right there, there's our arrow down if the pressure goes up, and vice versa. So if the pressure drops, the volume will get larger. So here's the problem. The pressure of a 5.71 liter sample of neon gas is 175.5 torr. So this first sentence is going to be one side of the equation. Calculate the new pressure when the volume becomes 3.4 liters. Okay? So I'm going to plug this into my equation. So I have 175.5 torr, and the neon gas was at 5.71 liters. So I'm solving for the new pressure, P2, and it says the volume becomes 3.4 liters. So now I need to solve this equation. How do I solve? I got to get P2 by itself, so I got to divide both sides by 3.4. And so I'm going to take in my calculator, I'm going to go 175.5 times 5.71 divided by 3.4. And when I do that, I get my pressure as 294.7. Okay? Now, what's the unit? It's whatever the other pressure was in. Pressure here was in torr, so this is going to be in torr. Because my liters is gone, leaving me in torr. So that's Boyle's law. And that says temp stays constant. Now, Charles' law. Charles' law states that the pressure stays constant. So here's our equation. V1 over T1 equals V2 over T2. As our temp increases, our volume increases. So the volume will increase, and it's going to be directly proportional. So as the temp increases, the molecules move faster and expand, increasing the volume. So a sample of gas occupies a volume of 450 liters at 273 Kelvin. What is the volume if the temperature increases to 310? Assume pressure remains constant. So that's why I know I'm using the Charles law equation, because my pressure remains constant, and so this equation doesn't use pressure. So this first sentence, 450 liters and 273 Kelvin, is one side. So my 450 liters over my 273 Kelvin, it equals what I'm going to solve for. I'm looking for the new volume, and my temperature is increased to 310 Kelvin. So how do I solve? I cross multiply and divide. So I'm going to cross multiply these guys, 450 times 310 divided by 273 Kelvin. So I go 450 times 310, I get a really large number, and then I divide with the one that is with my unknown. Okay, that is diagonal from my unknown. So I'm going to divide by 273, and I get 511 liters as my answers. Again, I know it's liters because I'm solving for volume. Last equation, or law, is Gay-Lussac's law. Gay-Lussac's law assumes that the volume remains constant. So if they say here, like in this problem, A sample of carbon dioxide is measured at 25 degrees Celsius, 3 liters, and 150 kilopascals. The temperature reduces to 273 Kelvin. The volume remains constant. Okay, because the volume remains constant at 3 liters, I'm going to cross it off. I'm not going to worry about it, and I know that I'm going to use Gay-Lussac's law. Because it states as temperature goes up, my pressure goes up. So the volume remains constant, so now I need to just figure out where everything else goes. A sample of carbon dioxide is measured at 25 degrees Celsius and 150 kilopascals. That's going to be one side. Problem is I cannot, absolutely cannot I cannot solve these problems with Celsius. I have to convert it to Kelvin. So Celsius plus 273 equals Kelvin. So 25 plus 273 is 298. So that's what I'm going to put in as my T1. And then my P1 is 150 kilopascals. The temperature reduces to 273 Kelvin, so that's going to be P2. What is the new pressure? So that's what I'm solving for. Same thing, I'm going to cross multiply. 150 times 273, get a really large number. Then I'm going to divide by 298. So I cross multiply this way, and then I'm going to divide by 298. Divide with the one that is with your unknown. So then I get my answer of 137.4 kilopascals. So goal here is with these laws is just to figure out which one I use. Once I figure out which one I use, it's actually not that hard to do the math if I can just plug things in. Think of like one sentence is most likely going to be one side of the equation, then the one with the what it's looking for is going to be the other side of the equation. And I just figure out of these three, dependent on what is staying the same. If the temperature stays the same, I'm using Boyle's. Here the volume remains constant, so I'm going to use this one. Thanks.